Hi guys, this is 2014 VCAA Exam 2 in Specialist Maths, and we're dealing with the extended response questions, and this will be part 1 of a 2-part series. I'll endeavour to get through the first 3 questions in this video, and then we'll leave the last 2 questions to part 2, if that's alright with you. Okay, question 1. Consider the function with rule f of x equals 9 over that x plus 2 times x minus 4 over its maximal domain. That looks nice and easy, doesn't it? Find the coordinates of the stationary points. Well, that would be no problem, wouldn't it, guys? It's three marks. Good heavens. Well, let's just go through the motions. We're going to find the graph shape. I always like to find the graph shape just myself before I get a bearing on what's going on, but it's just a reciprocal quadratic, so it won't be too erratic if it's a quadratic. There it goes. Now, that's the general shape of the graph of y equals x plus 2 times x minus 4, or x plus 2 times x minus 4 over 9, if you like. I'm just looking for the general shape, okay? These are very critical points to know, okay? This intercept and that intercept, and this positivity here, this positivity here, and this negativity here, because that's all relevant for the reciprocal. Now, if we want to do 1 over that, remember that this will become a vertical asymptote, this will become a vertical asymptote, because you can't divide by 0, you know that, don't you? This will be negative, this will be positive, this will be positive, and where it's above the x-axis, it's going to be positive for the reciprocal as well as the original. Where it's below the x-axis, it's going to be negative, okay? And the closer it gets to 0, the more it goes off into infinity. So it's pretty easy to figure out what this is going to look like, and there she be, guys. Now, stationary point. Find the coordinates of the stationary point. Well, it's just going to be where the derivative equals 0. But it's going to be very easy to work out anyway, because it's going to be halfway between these two x values, x is minus 2 and x is plus 4. Add them up and divide by 2, you get 2 divided by 2 is 1, so x is going to be 1. Plug 1 into the equation of the thingy, and you'll get your y coordinate, and that'll do it for you. For 3 marks, I can't possibly imagine why they'd be giving 3 marks to that anyway. But anyway, there's one stationary point, and the coordinates are 1 and minus 1. It all makes sense, doesn't it? Yes, you happy? Great. So that's the answer to that one. Easy, 3 marks. Here comes the CAS solution, if you like doing it with the CAS. There's the function put in as f1 of x, and then I've solved for the derivative equals 0, okay? And then I find the value of the function when x is 1, and that's where the derivative equals 0. But look, guys, without a feel for it, I don't trust CAS, you know, because CAS can do some pretty weird things. So I'm a little bit wary about the CAS at times, but that's the stationary point again. Alright, so part B. State the equation of all asymptotes of the graph. Yes, that's 2 marks. Well, that's more like it, but it's also very easy. The asymptotes are going to be where x is minus 2, x is plus 4, and of course don't forget the x-axis, which is where y equals 0. They are the equations. Nice, easy marks, hey. If you want some CAS support just to back yourself up, you would do the graph of it, and you would be verifying that you've got x is minus 2, x is plus 4, and also y equals 0. Don't forget the y equals 0. That's the one that students are more likely to forget. Okay? Alright, very good. That was nice and easy. Alright, what have we got here? We've got sketch the graph of f, where x goes from minus 6 to 6 inclusive on the axis below, showing asymptotes, the values of the coordinates and any intercepts with the axes and the stationary points. Well, we just have to be careful we do a checklist at the end that we've got all those things. From minus 6 to plus 6, alright, we'll have to work out endpoints and the whole shooting match, guys. That's the function. So when x is minus 6, we've got to work out what the value of the function is for that. Does that look right? I think so. Yes, yes. So it's going to be 9 over 40, isn't it? So, alright. That's 0.225, apparently. And when x is plus 6, we do the same exercise, 9 over 16, and that comes to 0.5625, apparently. Exact values, by the way. Now, that's done that. Now here's our graph, because we had a feel for it from before. And what have I done? I've got that in, I've got that in, I've got that in and labelled, I've got that in and labelled, I've got the stationary point here. Oh, and I've had to work out an intercept here, a y-intercept. So when x is 0, you can easily see that's going to be minus 9 over 8, can't you? Right? Yes, you can. Alright, I think that's everything. Now, we better do the checklist, guys. Showing asymptotes, check a Rooney. No, I didn't do the... Ooh, I didn't do the y equals 0. Just a moment, and I'll fix that. Abracadabra, there it is. Now, just making sure. Let's go over it again. Showing asymptotes, that's now done correctly. The values of the coordinates of any intercepts with the axes, well, that was a y-intercept, wasn't it? Done that. And the stationary points, and we've done the stationary point. Yeah, everything's good, and that's worth 3 marks. So, guys, another 3 easy marks. Looking very good. Now, the region bounded by the coordinate axes, the graph of f, and the line x equals 3 is rotated about the x-axis to form a solid of revolution. Okay, for the next question we write down a definite integral in terms of x that gives the volume of this solid of revolution. And this is worth 2 marks. Alright, let's go for it, guys. Now, you've got to get clear in your head what we're doing here. So, what was it again? The graph of f, the line x equals 3. Yeah, okay. The coordinate axes. Yeah, right, the coordinate axes. So that's the y-axis, the x-axis, this little block here. X equals 3 is rotated. That should be pretty easy, I think. 2 marks. Alright, so let's go for that. So it's pi, don't forget the pi, by the way. Y squared dx from x is 0 to x is 3. Now we put the y in. There it is, guys. I think that's our definite integral, isn't it? There you go. I've just cleaned that up a little bit, actually. Just squared the 9 and stuck it out here. But that's it. There's 2 very easy marks for us. And find the solid of revolution volume corrected 2 decimal places. Well, that's just a CAS thing. 1 mark. Let's go for that. And that's it. 12.2 decimal places. So 12.85 would be the answer to 2 decimal places. Whoopee-doo. Nice easy question to start off the paper, wasn't it? Question 2 now, worth 13 marks. Complex numbers. Here we go. Consider the complex number z1 is root 3 minus 3i. Express that in polar form for 2 marks. Well, I can certainly do that for 2 marks. Can you? So, draw a little picture. I always recommend you draw a little picture so you don't get it wrong. So we're driving the car out from the garage, which is the origin. We're going root 3 units out to the right and then 3 units down. Okay, we've got to work out what alpha is, that little angle in here. Okay, the angle whose tan is 3 over root 3 is going to be the same as the angle whose tan is root 3 over 1, which will be pi over 3. So it looks like we're dealing with an argument of minus pi over 3 because we're going this away. Yeah, that's pretty straightforward. And the modulus is going to be that thing there, which works out to be root 12, which would be, what's root 12, guys? Come on, quick. 2 root 3, isn't it? Yes, good. So 2 root 3, and we've got the angle, yeah, minus pi on 3 is the argument. So therefore, z is 2 root 3, cis minus pi on 3. Correcta mundi, yeah? 2 marks. Pretty easy for 2 marks. What's next? There's the CASI version of it. Wait a minute, what am I doing there? Yes, I'm doing that. Oh, yes, and I'm just converting it to polar form for you. And it comes up with this funny looking thing here. And that's the way the TI CAS handheld does it anyway. Where this beastie here is your modulus, and this beastie up here, there, the minus pi on 3 bit anyway, is the argument, right? So you can just say that Z1 is 2 root 3 cis minus pi on 3, and you're laughing. Find the argument of Z1 to the 4th is the next question. Well, that's going to be very, very easy, because we know that the argument of Z1 was minus pi on 3, don't we? So therefore, the argument of Z to the 4th is going to be 4 times that. Now, we just have to put that in principal argument form. If you just do that in your head, minus pi and then minus another third of pi. If you add 2 pi to that, you are going to get that. You will. You'll get that. That's our principal argument, okay? If you don't want to add 2 pi, just work it out in your head where you are in the quadrant situation. Using CAS, there we go, the argument of that. No problem. Look at that. Very easy. Next question. Given that Z1 is that thing, is one root of that equation, find the other 2 roots. Okay, for 2 marks. No problem at all, guys. Let's do that. So we know that the polynomial is that thing, and we know that that is going to be equal to that thingy, that factor, times that factor, because remember the conjugate root theorem applies here because these coefficients are real, okay? So that's automatically a given to us that this is going to be another factor, times the third factor, which will be a linear one, okay? So the other 2 roots, we've got to convert them into roots, remember that, don't let us forget that. So this is the manual way of doing it. Okay, yeah, we get that, don't we? Yes, we do. And that comes to that, doesn't it? After I multiplied it all out. Yes, it does. Yes, yes. And now we're just going to work out what alpha is for this last linear factor, which is really, really easy to work out. So we're saying that z cubed plus 24 root 3 is equal to this, right? So therefore you can see that this 24 root 3 has to come from the product of this last term in this bracket, the plus 12, times this last term in this bracket, which is the minus alpha. So minus 12 alpha has to be plus 24 root 3. Yes, it does, and therefore alpha is going to be minus 2 root 3. We're converting them into roots, aren't we? So therefore, this, just be careful you don't get all tangled up with your factors and your roots. If alpha is minus 2 root 3, then that is the root. That is the root, right? You get that? Because this is z minus alpha is the factor, which would be z plus 2 root 3. If you get my meaning, just think about that. We get this and we get that. They're the other 2 roots, yeah? Alright, you're happy with that? Here comes the CAS. Here comes the CAS, guys. If you go C-solve, complex solve of that thing there, I'm using X, doesn't matter, you'll get that. It's very quick, isn't it? So you might have preferred to use the CAS for that. So to gain 2 marks with a purely CAS approach, ladies and gentlemen, what I would recommend is this. State that root 3 plus 3i is a second solution because of the conjugate root theorem, given that this beastie here, this polynomial, has real coefficients, and then just specify that z is minus 2 root 3 is the third solution from CAS, and therefore you get the roots that we already gave in the previous screen to that. Alright? Alright, what have we got here? We've got to find the value of this, where Z1 is that. Now, I just want to point something out to you guys. Having a look at this, this has got me a bit intrigued because I can see the elements of a circle there. So, please note that if you have something of the form Z minus some complex number, which we'll call C, times Z bar minus C bar, and if that equals some number which we can call R squared, you got yourself the locus of a circle, guys, where the centre is at C, this beastie over here, and the radius is R. So this looks like this is coming up to be a circle. So let's just do this question and see what we get. This Z1, in this case, is this number here, root 3 minus 3i. So let's just go with it and substitute that in and see what we get. In general, if you substitute x1 plus I y1 for z1, you'll get this, okay, and we'll substitute the actual numbers in a moment. So we get that because it's a difference of 2 squares. It's x1 squared minus I squared times y1 plus 2 all squared, and the minus I squared bit gets you plus 1, so that gets you that, alright? Now substituting in the actual values for x1 and y1, we get that, and that gets that, and then we get that. That's 4. Okay, so that's the answer to that question. But just as a little PS, I want to just point out to you, so if we have z minus negative 2i, which is the same as this thing. If c was minus 2i, it would be of this form here that I've got in the note, okay? So z minus negative 2i times z bar minus the conjugate of that. If that equaled 4, then you've got yourself a circle where the centre of the circle is at 0 and minus 2, aka minus 2i, and the radius is 2. That would be a circle of that centre and that radius, and this point here, z1 is root 3 minus 3i, would be on this circle of that equation there. Okay, that's just what I want to point out to you. So that the relation blah 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 can be expressed in Cartesian form as a circle with a centre of 0 and minus 2 and a radius of 2. Okay, well we can do that, can't we? Let's go for it. There we go. We've just got z here instead of z1, right? This is just any old z that's on the circle. So z plus 2i times z bar minus 2i equals 4. If we substitute x and y, x plus yi, for the value of general z, we do that, and we just go through the motions, guys. We could get that if I group the I terms together, and then this becomes a difference of 2 squares, doesn't it? You see, it's going to be x squared plus y plus 2 all squared, which is this beastie up here, which makes us very happy because we've done it. There it goes. There it goes, as required. Nice, huh? Very excellent. Right, sketch that thing on the axis below. Well, this is where it came in handy, you see. It wasn't useless information because the centre was 0 and minus 2, and the radius is 2. And there it goes. Jolly good show, hey? Yep. Usually these questions they're part of a story that's being put together, so we picked it, didn't we? We certainly did, guys. So I'll just put that little point there from part B1 on the curve for you there. That was root 3 minus 3i, just to show you that that's on the circle, okay? Well, this is very cruisy, isn't it? We're going very well. It must be going to get harder soon. What do you think? The line join... this bit, I remember this bit. Funny me saying, I wonder whether it's going to get harder. If you were getting into cruisy mode, this is the bit which puts you back in your box. So have a good look at that. Well, have you picked yourself up off the floor yet and collected yourself together again? Well, the thing about this question is, look, it's under exam conditions if you were doing it in an exam situation, and this looks really freaky, doesn't it? So let's just read the question again. The line joining the points corresponding to some point k minus 2i and another one minus 2 plus ki, the 2 plus k being in brackets where k is some negative number, is tangent to the curve of this circle. And we've got to find the value of k. Well, you know, how would you do this when you're already a bit stressed? But look, it's always simple to do these things. The answer is never very far away. You've just got to basically believe that, and if you've done enough practice, you'll be able to see through it. It's kind of like a bit of a methods question in a way, except that it's got complex numbers in it. So come on, we'll pick it apart bit by bit. What I think we could do, the tangent thing is getting me. So it only intersects at one point, just grazes the circle at one point, right? So why don't we get these 2 points here and work out the equation of the line in terms of k, because we can easily do that. Equation of a line, we can get the gradient, and we can get the equation of the line because we've got 2 points and the gradient as well. Then we've got this circle here. Now, if we then solve the line joining these 2 points simultaneously with the circle, and then just use the discriminant equaling 0 for one solution, it should all just drop out with a value of k for us, remembering that k has to be negative, and then we'll be okay, won't we, guys? So let's do that. So the strategy, as I said, we'll find the equation of the line joining those 2 points with the k's in them. Then we'll set up the equation for the intersection of the line and the circle. and then we'll solve the equation for only one solution point using the discriminant equals 0, okay, for a tangent. So once we've got a game plan, it's not half as bad. So there's the 2 points. Let's work out the gradient of them. So it's going to be y2 minus y1 over x2 minus x1, which all comes out to be, my goodness, minus 1. How interesting. Alright, the equation of the line, passing through, let's pick this point's probably a bit easier. It doesn't really matter though. With this equation here, where m is minus 1, and x1 and y1 are going to be the point, that'll be x1, that'll be y1, and we'll get that. Looks alright, doesn't it? Yeah. So that looks like our equation. Now, that's equation 1. This one's equation 2, the equation of the circle. Now we've got to set them equal to each other. So sub for y from equation 1 into equation 2 is going to be a little messy. That's going to be y, yeah, for y. Oh, goodness. Okay, well, let's do it. Come on. We can use our calculator. So we've got x squared plus a beastly looking thing squared equals 4, but actually it's not so bad. Not so bad, because those 2's will cancel. And we've got that. Alright, not so cataclysmic after all. We can do that, and then we can simplify that a bit. Now let's get Mr. Discriminant on the job. Hello, Mr. Discriminant. We've got this, that's the b thing, the b term. B squared minus 4 times a times c. That has to equal 0. Now, what's that going to do to us? Oh, very nice. Look at that. We get that, and therefore k squared is going to be 8, and therefore k is going to be minus 2 root 2, because remember k was less than 0. We've worked it out, guys. Pat on the back for you, and let's go onward ever onward. Oh, there's the graph of it. I did a graph just to show you how impressive it is. See that? Look, there's, once you work out what k is, they're the 2 points, and you can see they just touch the circle beautifully, don't they? Pretty amazing, eh? But a very nasty little question, in fact probably the hardest question on the entire paper. Alright, question 3. We've got some vectors now, vector A and vector B, and we've got to do, for part A, we've got to express A as the sum of 2 vector resolutes, one of which is parallel to B, and the other of which is perpendicular to B. And we have to identify clearly the parallel vector resolute and the perpendicular vector resolute. Well, very straightforward, and it's worth 5 marks. Goodness me. How do they get 5 marks out of that? I don't know. Let's do it. It's really easy. You know how to do this. Goodness, you could do it in your sleep. If you've done any practice, you could. So A is equal to the resolute of A parallel to B plus the resolute of A perpendicular to B. Okay, so there's my formula for the resolute parallel to B. That's the one I like to use. Nice and easy, because you don't have to work out magnitudes of vectors using that one. It's an absolute snap. So it comes to that. And if we work it all out, we're going to get that. What's that? 6 minus 5. It's just 1/9. 1/9 of B. Goodness gracious. Well, that's very nice, isn't it? So therefore, we get that. We get that. Very interesting. So that's the parallel resolute. Let's do the perpendicular resolute now. If we have this equation up here, we know that the perpendicular resolute is just A minus the resolute of A parallel to B, which we've just worked out up here. So that makes that very easy. And we're just going to go through the motions, being careful not to muck it up, because it's a pretty easy question. Alright, just be careful. We've got things over 9 here. So 3 9s are 27. Take away 2 is 25, 2 9s are 18, plus 2 is 20, and 9 over 9 plus 1 over 9 gets 10 over 9. Everything's looking really, really great. And I'm just being very careful down here too, because they've just gone on about this, identify clearly which resolutes which. I'm just going to write them out so that I make sure I get my 5 marks. So there's the parallel resolute, there's the perpendicular resolute with a 1 over 9 out the front with a bracket, and that's 5 marks for us, guys. Are you happy with that? I think it's pretty delightful. Okay, for CAS, now how would you do this with CAS? You'd put that in there as A, that one in there as B, Then you would do the formula for the parallel resolute. That would be dot product of A with B over the dot product of B with B times B, and you would get that. Isn't that beautiful how it does that? And then the A minus this one we got here, this answer we got here, is our perpendicular resolute. Now, guys, I would, for 5 marks, because I'm not sure where those marks are coming from, I'm going to do it the manual way, I think, and then I'm just going to do the old CAS thing just to make sure I'm right, I think. That's what I would do just to play it safe with that question. Yeah, that's A parallel to B, that's A perpendicular to B. Alright, next bit. We've got OABC here, which is a parallelogram where D is the midpoint of CB. So D is in the middle of this side here. OB and AD, wait a minute, OB and AD intersect at P, alright, got that. Let OA, this one, equal vector little a tilde, and this one here is little c tilde. This little wavy waggly thing is a tilde, in case you didn't know. Right, given that AP is alpha times AD, so AP is alpha times AD, yes, I get that. Write an expression for AP in terms of alpha, A and C. Well, that's a pretty easy question for 2 marks. No problem. So putting in all the numbers and everything and all the information, this one here, AP, is alpha times AD. This is 1 minus alpha times AD, in case you see the fractional thing. That's, you've got to work it out in terms of fractional components, yeah, in case we need to do that. Now, arrows all in the right spots and everything, that's looking good. So therefore, AD, now working that one out first, AD is going to be AO, let's do it, AO plus OC plus CD, which is a half of CB. Do you get that? Very good. So it's minus little a plus C plus a half of little a, which gets us C minus half of little a, and therefore AP is going to be alpha times that, right? Yeah? So it's alpha times all of this up here, because all of this up here is AD. You happy? Good. Well, that was pretty easy, wasn't it, for 2 marks? Now, given that OP, where's OP gone? Oh, okay, yeah, okay. OP is beta times OB. This is all leading somewhere, guys. I'm getting a premonition here. There's going to be some little proofy thing coming out of this, I think. So this is beta times OB. We can do the same thing. AP in terms of beta, A and C, exactly the same thing. That's only worth 1 mark, though. All right. So OB is, all right, did you get that? OB, it's going to be this one plus this one. Yes, you get that. So therefore OP is just beta times that, yeah? All right. Now, hence AP is going to be, so AP is AO plus OP, because we've just been working out OP, this diagonal bit. So therefore we're going to get that. So we get that thingy there, don't we? Yes, we do. And that's our answer. All right? So that's the answer for AP. All right? Done another different way. So just collecting our thoughts, because you've got to keep track of the story in your head, because these questions have a kind of a story unfolding. So we've actually worked out AP 2 different ways. One of them involves alpha, one of them involves beta. So I'll bet you what you like that we have to find out the value of alpha and beta, because that's how they do these kind of questions. Oh, funny about that, of course. All right, so it's going to be really, really easy. From part 1 we got AP was that thing. From part 2 we got AP was that thing. So therefore it's just a straight equating coefficients thing to work out what we're doing. So you can say that by equating coefficients we can say that this bit here, this minus a half alpha from the minus a half alpha A term, will be equal to the beta minus 1 from this A term here, right? That's the first thing, and then we can do the same thing with these C ones, okay? So we can say that therefore, because we know that alpha C equals beta C, therefore we can say that alpha must equal beta. So now we've got 2 equations, 2 unknowns. Bob's your uncle, and here they go. We're going to solve them now. Sub A equals B from 4 into 3, and we get that. And when we just whittle that down a bit more, we're going to get, 1.5 times b is equal to plus 1, therefore b is 2/3. And a equals, alpha equals beta, I should be saying, equals 2/3. There you are, there's the answer. That was worth 2 marks. That was a vector proof, guys. They don't often put vector proofs in these papers, so we just got one, and it was nice and easy, wasn't it? Alright, so that brings us to the end of question 3. So we've done questions 1, 2 and 3 on the 2014 VCAA Specialist Maths Exam 2 paper. And remember, guys, these are just my unofficial solutions, alright? I hope you got something out of that, and we'll see you soon. All the best.